This is the Your Turn number 1 in section 3.4 Equations and Graphs of Polynomial Functions. This is a polynomial where we have two factors, x minus 1 and x plus 2, and they both have exponents of a 2. When you expand, we know that we're going to get a quartic, and the factors will be determined by setting them both equal to 0. So when I set x minus 1 equal to 0, I will get x equals 1. When I set x plus 2 equal to 0, I will get x equals negative 2. The zeros of the function are x equals 1, x equals negative 2, but we're also going to determine the multiplicity. The multiplicity is determined by the exponents. They both have 2, so I know the multiplicity is 2 for both. But I also know by looking at the graph the multiplicity is 2 because at the x-intercept 1, the graph approaches the x-intercept, hits it, does not go through the x-axis, but bounces off. At negative 2, the same idea. It approaches the x-intercept, hits it, and then bounces off and goes back up. So there is no sign change in the y value. The y value before negative 2 is positive, and the y value after negative 2 is still positive. No sign change. So the next thing we're going to do is look at the positive and negative intervals. Again, when we look at the positive intervals, we're looking at where y is greater than 0, not equal to 0. And we're looking for y is less than 0 when we're talking about a negative interval. If y is greater than 0, the function should be above the x-axis, and if it's less than 0, the function should be below. So when we look at this function, I can see that we still have two x-intercepts as mentioned above, and if I do a number line, a sign diagram, and place those x-intercepts on my number line, we can determine where the y values are positive or negative. And visually it's just more appealing. So to the left of negative 2, I know the function is above. So I know the y values are positive. When I look at the y values between negative 2 and 1, I can see the graph is increasing, then decreasing, which means the y values are still positive. To the right of 1, I can see that the y values are still positive because the function is above. So it looks like, and it is, the function is positive everywhere in this interval. So how do we state that? If it's everywhere, that means I'm going from negative infinity to infinity. However, there are certain x's I can't have because their x-intercepts is where y equals 0. So we have to remember that. If it's equal to 0, I don't want it, just greater than. So I know it's equal to 0 at my x-intercepts, which would be negative 2 and positive 1. In this particular example, there's no function below the x-axis, so we do not have a domain for the negative interval. So I'll just say not applicable.